Hi, I'm planetary scientist Pascal Lee. As we prepare to return to the moon, one of the big decisions we're going to have to make is decide where to send humans. We might visit different sites, but also we might choose one where we would set up a base and stay there for the long term. I've been examining the lunar surface in more detail lately, and I think I might have found a really exciting place for humans to go explore and possibly settle. It's inside a large crater near the north pole of the moon. The crater is called Philolaus Crater. It's named after the Greek philosopher Philolaus, who was actually the first to propose that the Earth might not be at the center of the universe. Anyway, let's talk more about why this site is so exciting.
4, 3, 2.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The Apollo program taught us a lot about the moon, and in particular about the origin of the Earth-Moon system. We now think that the moon was formed when an object about the size of Mars collided with the Earth very early in the Earth's history. And the impact was so violent that the incoming object was mostly destroyed, and in the process, a big chunk of the Earth's mantle and crust were thrown into space. All this debris was superheated and eventually formed a ring of debris around the Earth, which over time reaccreted into what we now call the moon. So the moon was born from this very fiery beginning, and because of that, it started off mostly devoid of water. So the moon is not completely devoid of water. We now know that there's water trapped in the minerals of the moon, and also relatively large amounts of ice in the polar regions of the moon. At the poles of the moon, you have areas that are permanently shadowed. They never see sunlight. And in these permanently shadowed areas, the temperature can be extremely low, typically minus 250 degrees Celsius. And so these places serve as traps, cold traps, for water ice. And so that has been a big discovery, because being able to access water ice on the moon means that you can have water for hydration, but also use water in the future as rocket fuel. You can break down H2O into hydrogen and oxygen, and that's going to be rocket fuel that will cheapen your journeys to and fro the moon and also out into the rest of the solar system. Now, the good news, therefore, is that there is water ice on the moon. The bad news is that it's going to be very hard to extract it at the lunar poles. This ice is buried in this gritty regolith, this soil, and so it's going to be very hard to extract. You're going to have to bulldoze tons of material to extract this ice. And then you're also going to have to operate in these permanently shadowed areas where you don't have access, easily at least, to solar power. And so how are you going to keep your equipment warm? How are you going to even power your equipment? This is going to be a challenge. And so if only we could find a cave in the lunar polar regions that could give us easier access to underground ice. So over the past few years, scientists have been finding at lower latitudes a number of unusual pits in the lunar surface. These pits are different from regular impact craters. They look like openings into underground caves. Many of these pits are found along these winding channels running across the lunar surface called sinuous rills. Sinuous rills are generally thought to be collapsed or partially collapsed lava tubes, which are underground tunnels that were once streams of flowing lava. The pits found along the sinuous rills are holes in the roof of these lava tubes, and for that reason, they're called skylights. Lava tube skylights are really amazing features on the moon because they represent access points into underground caverns. But of the over 200 pits identified up to this point, none are located in the moon's polar regions. And because of that, it's not clear if any of them would likely lead into lava tubes that contain ice. So, to expand our prospects of finding ice on the moon, I became interested in the possibility of finding lava tubes and skylights in the polar regions of the moon. On Earth, when you have a lava tube in a very cold place, there's often massive ice sheltered inside the lava tube. On the moon, if lava tubes existed near the poles, temperatures inside these caverns might stay low enough to allow water ice, if it's present, to survive over very long periods of time. So I combed through hundreds of images of the polar regions of the moon taken by NASA's Lunar Reconnaissance Orbiter, looking for lava tubes and skylights. And incredibly, inside the crater Philolaus, near the north pole of the moon, I spotted these intriguing small pits. Now, Philolaus Crater is located at 72 degrees north, about 550 kilometers from the north pole of the moon, on the moon's near side. The crater is outside the permanently shadowed areas of the lunar poles. Philolaus is large, approximately 70 kilometers across, and in the northeastern part of the crater, there's a relatively flat region that was once a pool of molten lava with these sinuous rills, in other words, collapsed lava tubes crisscrossing the surface. The intriguing pits I saw were located right along sections of these rills. The pits are small, typically 15 to 30 meters across, with completely shadowed interiors. This was really exciting because here I was staring at what might be the entrances to an underground network of lava tubes near the north pole of the moon. So what are the next steps? Well, the first step will be to acquire higher resolution imaging to make sure that these pits are truly lava tube skylights. If we can confirm that they're lava tube skylights, then the next step will be to figure out if these lava tubes contain ice. And that actually is going to be a very exciting phase of exploration, because that's going to take humans or robots on the ground. We're going to have to explore these lava tubes, and we're looking at a new generation of caving astronauts or spelunking robots to do this. And this whole idea of exploring caves on the moon is something that I actually grew up with as a childhood fantasy. Even Tintin and his dog Snowy, which were childhood heroes of mine, explored caves on the moon in which they found ice. Now, there are other aspects of the Philolaus Crater site that I think are appealing. Number one, it's a relatively young crater. It's probably less than 1 billion years old. And this might sound old, but in a relative sense, compared to other things on the moon, it's actually relatively young. And so by exploring Philolaus Crater, you get an opportunity to explore sort of the recent history of the moon and what has happened to its materials in recent times. The other thing, of course, is that when you are at Philolaus Crater, you see the Earth, and that means that you can have direct communications with the Earth. You don't need a relay satellite. You just point your satellite dish to the Earth, and you have comms. So that's actually operationally a very practical advantage to have at a lunar site. And then the third aspect, I think, that's appealing to me, at least, it's this, and it's almost icing on the cake, and that's the fact that you will have a beautiful view of the Earth from Philolaus Crater. The Apollo landing sites were all near the equator of the moon, and that means that the Earth was essentially hanging almost right overhead for the astronauts, and they would have a hard time seeing the Earth. They would have to bend backwards in their suits to catch a quick glimpse of the Earth and then just continue on with their work. Here at Philolaus Crater, the Earth will be hanging in the sky like a giant blue marble over the mountainous rim of the crater, just over the horizon towards the southeast, and it will just be an incredible sight to see the Earth from Philolaus. And then I'm intrigued by what lies ahead, farther ahead. Exploring the lava tubes of Philolaus Crater on the moon will actually be a fantastic practice for exploring lava tubes on Mars in the future. And we know that there are lava tubes on Mars. We know that many of them have skylights. In fact, they are spectacular. And most of these lava tubes and skylights on Mars are found on the flanks of the giant volcanoes of Mars. these volcanoes are not erupting right now, but they might still be active and only dormant. And so maybe their interiors are still warm and cozy. Maybe there's moisture in there. Maybe these lava tubes on the flanks of the Martian volcanoes have ice in them and possibly even signs of life. And so to me, there's this incredible prospect of really getting some practice exploring lava tubes on the moon to get ready for exploring and searching for life in lava tubes on Mars.